Thank you, Mark, for this. Hello, everybody. If you're eating, I'd like to say bon appetit to all of you, and welcome back to the NYUMC class. This is an introduction to Python, and today I will give you the lecture number 12. So you will see that it's a pretty linear follow-up from the previous lecture that was focusing on NumPy and pandas. However, today we are going to actually look at a little bit more pragmatical examples. So I will give you a little bit of time to get the lecture using the typical Git commands that are now accessible on the chat. So I'll let you enter these commands. Please, if you have any issue, you can tell us on the chat again, and we might help you. Again, if you have some issues, you can use our Stack Overflow page that actually has a lot of information to help you to not only download the documents and all files required for that class, but also you'll find some information about the contents of Python commands. And please use it if you have any questions and if you want more details about what we're going to see today. So again, here are the commands. Okay, so this is here an example of a page from our Stack Overflow. And I will start. I think I will try to have an introduction a little bit shorter than last week so that we'll have more time to describe all the commands that we're going to use. And this class will focus on the three different aspects. So again, I will start by giving you a little recap on how we can access and index the data with NumPy and pandas. I think I gave you examples that were maybe a little bit too complicated last time, so I will simplify it a little bit. And this is very important because NumPy and pandas, they will offer you a lot of functionalities to deal with very large data. And when you have large data, it's important to have efficient tools to access some information. And another important aspect when you have large data, it's to be able to visualize it. And for that, we are going to today introduce you to a new module that I really like. It's very popular and it's becoming really like the gold standard for plotting with Python. And it's called Matplotlib. So we are going to give you some introduction. Matplotlib is a fantastic library. So of course, today we're not going to be exhaustive in all the functionalities that are accessible with that module, but we would like today to give you some example about how we can quickly have nice plot with the Matplotlib. And at the end of this class will be focused more on some examples that actually will put together some ideas about how we can reshape our data, filter the data, and plot the data. Could be either a NumPy array or a Panda data frame. You'll see that you'll have many options to do this. Okay, so again, I give you the link for the class. You can click here and you have some all information about the previous lectures. You can rewatch all the lectures. You have all the videos accessible on this link. I will give you also some important links that you can use. These are the official web pages for NumPy and its add-on, SciPy, that has a lot of additional functionalities for scientific programming. Then Panda, Matplotlib, and again, I would like to recommend this great webpage that I particularly like called Towards Data Science that contains a lot of information about how to use Panda, NumPy, and Matplotlib together. Also, quickly, don't get overwhelmed if you believe that there are so many functions and names to remember. You can always use one of these beautiful cheat sheets. I personally like to print them. I can just give you an example. you click here, they are PDF. I like to print them, and you have a list of commands. I can show you another example for Numpy. And basically, yes, you have here a good summary of all the different functionalities that you can play with. I print them and put them in a plastic folder like that. They're great. So I encourage you to always have these documents next to you when you use these modules. Okay. So let's go. Also, this book is great. It has a lot of information about data science. I think you might find it online. It's a book published by Aurélie. It's a classic, and there is again a ton of information online. So use Google and ask a question about Panda and Matplotlib. You'll find tons of information. Okay, so the first thing we have to do it's to import again Numpy and Panda. So I give you again these 2 lines that are basically always the 2 lines that you should start with when you have a blank document. We'll import Numpy and use this little keyword so that we don't have to write Numpy every single time that we call one of the Numpy function. Same for Panda. Don't change them. They are pretty standard. And let's go. So I run it. Okay, it's working. I would like to say that for clarity and because I like actually to switch from web page to my actually Jupyter notebook, I'm using Chrome for this presentation. But keep in mind that it will be exactly the same on a Visual Studio Code. I think it looks nicer, and I prefer to use this tool for this presentation, but it's exactly the equivalent. Okay, so we'll have a first recap about how to access elements on a Numpy array. So to start simple, we'll start with a one-dimensional array. Again, array is great to keep information that could be multidimensional, but we start with a 1D array, which is similar to a simple list. So we imported now Numpy, so we can use the command np.array, and array can actually take as an argument a list. So here's a list of integers from 0 to 9, and then X will be now an array object that we can actually we can access to its element using this typical syntax. So between brackets, we can have either use I, J, and K between semicolons, and this actually corresponds to the starting index I. J, it's the stopping index. K, it are the steps or the increments between I and J. So I think nothing is better than give you an example. So if you want the third element, you're just going to have access like that, right? So it's going to be a bit slow, but at least you'll have time to see how it's working. So now if you want to have the third to the fifth element, you can just do this again. Here we don't have to use print because Notebook Jupyter does a job. Everything that is at the end of the block, it's actually by default printed. Then I can use here this command. So in this case, when I don't put anything as a J or K argument, it means that it will basically take whatever starting from 3, the third element. And this is what we have here. So we are missing 0, 1, and 2. Again, we can use here for J, which is the stopping index, we can use a negative integer. And in that case, it takes everything until the 7th to the last element. So here we have an array containing 3 integers, and we can also use the increment. So that's now an example where we use an increment. So here we'll have an array from the the element the first element here to the 7th, and then we are going to use an increment of 2, which means that we'll have only now these odd numbers. A little trick that could be useful for you also is to use a value of k that is negative. In that case, I could be superior to j, and if we do that, now we are actually starting from a value that is actually 8 to 2, and we are going to use the negative increment of -2, so that the result will give you this array containing 8, 6, and 4. Okay, I think that's something that you already had in your mind, because it's very similar to actually, if you're using R, it's a very classical way to access one-dimensional data. What about now 2D array? And here I'm just using an example about 2D array, but keep in mind that you can apply these rules for multi-dimensional arrays. And I think here you have an example for actually multi-dimensional arrays. So the first thing, we have to create a 2-dimensional array. So we can actually create the array here from a list that contains 3 lists. So it will be actually an array that will have a dimension of 3 by 3. And we can actually pull different information using a very similar way to index. There is a difference here. The difference is that we can actually now use a comma if we want to pull columns, or if we want to pull rows. So let's give you an example now. So first, we're going to create this array. Okay. I like maybe to switch to another example. This array is pretty short. Remember that you can create an array with a range. I'm going to comment here the end. And so this array will look like this. Okay, so starting from 0 to 24, it contains 25 elements. And I can reshape it if I want. I can reshape it and give him the number of rows. Here it will be 5, and the number of columns. And then if I run it, here now you can see that I have a reshaped array with actually 2 dimensions. So what I can do now, I can actually, I can have access to, let's go step by step. So this. So if I take, for instance, here 0, 0, and now what I'm taking here, I'm taking the column, the row 0 and the column 0, and I have this value. Again, I can change here now this value, and now for that array on the row 0, I can take the column 1. I can also get multiple columns or multiple arrows that way. So again, here we are going to use the column keywords, and here between this comma, we are going to have access of here the rows and there the column. So let's run it. And now you can see that here I only, let me start here up. So I have now the first, so 11, 16, and 21. So I have the first, the column number 1, so this one, this is the column 0. And then I have everything starting from the second row, which is here 11. That's why we have these 3 values. Okay, so you see, I mean, you get familiar to that, and this is a very nice way to then decrease and the size of your array and retrieve information that you want. You can also use more fancy indexing. Here, I'll show you here the result of this command. So now what we have is just we have the column, and also this is a very nice trick that you can use. You can use the transpose method that is already included in arrays, and you can actually transform an array of columns in an array of rows like that. So I think there is a ton of documentation about indexing. You will get familiar. We are going to show you later in this class other examples, and you'll see it's a very nice way to select subregion of an array. Okay, so now that was a recap on the Numpy array. We can also get elements or field in a Panda data frame. So there are two different ways to do it. One is using lock, and the other one is using ilock. So again, they're very convenient when you play with a data frame, and I'm pretty confident that you are going to use them if you get familiar with pandas, and they're important to be clarified. So first, ilock. So ilock, I would say it's maybe the simplest one. So it will access rows depending on the integer index. So basically the syntax is that way. Here, this is the name of the data frame, then a dot ilock, and then here you can get the row that you want. So here going to be the first row, okay? But you can also give to ilock a list of rows. So let's see how it works. Okay, so first I'm going to comment. Okay, so so here we're going to create a Panda data frame from these dictionaries. We're going to use this command to transform these dictionaries into a data frame. That's an example that I used actually last week. Okay, so now I'm printing the F. So you can see that we have 3 lines corresponding to trees, and they are described by 3 features: the girth, the height, and the volume, with actually float values, or here integers. And if I now, so we have 3 lines, okay? And you see that the first line is the tree number 1, and the second line is a tree number 2, and the third line is a tree number 3. So that's easy to keep in mind what's happening. So here I'm gonna pull the first, the second, and the third line, and that's what's happening. So we basically retrieve the entire data frame, but we can actually reverse the order. I can now start with the last one and finish with the first one, and you see that now it's reversed. So that's a very actually nice way to select a sub ensemble of rows from your data frame. Okay, I'd like to say that since it's very important that you keep actually your index as a unique keywords, you might be careful about having duplicates. And so typically when you use ilock, if you have twice the same index, you will have a duplicate. And I think the problem is that it's still like you have here now a data frame with a duplicate, and it's not something that probably you would like to avoid. So to make sure that you don't have duplicates, you can do a couple of things. First, you can, the trick that you can use now that you're familiar with list and set, but using set, you can actually make sure that you don't have any duplicates in your list. So remember how set is working. I'm going to print sets here of this list, and oops, sorry. Parentheses. Okay, exactly. So that's a set, and you see that set actually nicely remove one of the index that was duplicated. Then you can transform as a list, and you can give it as then ilock. You can also do something else. You can use a method that is already implemented in a data frame. It's called drop duplicates. So if I run it, now you can see that it removed one of the duplicates. And again, this is an example, but I encourage you to go to the Panda webpage, and you'll find a lot of very useful methods that you can use, such as drop duplicates. Okay, so you can, that's a way to actually pull out some particular rows from a data frame. Now you can use another system, and you can use now log. So the first one was ilog. Now we're going to play with log. And what log can do is that you can actually, it's a very it's a very efficient way to pull rows. And you have here different ways to pull rows with log. So first you can give the name of an index. You can also give a list of indices, but you can also give a Boolean list, like here. So in the first case here, you're going just to retrieve the line where the index is 3, 2. Here, you're going to have 2 lines corresponding to 3, 1, and 3, 3. And here, what we can do is that we can use this Boolean that will tell us if actually we want the first line, the second line, and the third line. And what it should return here is just this line corresponding to 3, 2. So something is important is that if you use this Boolean list, the number of Booleans should match the number of rows. That's a condition to use it. And that's a very useful way to pull out data. I'm going to give you some examples here. So we can start with this example where we just want to retrieve 3, 1, and 3, 3. Okay, we could also doing that way. Okay, there is a little subtleties. If you remove this bracket, it will return a series, which is a different data structure than a data frame. But that's a subtleties. I would like to not make things complicated. So here with this syntax, you can just return a data frame that contains 1 line. And you can use all methods that are associated to data frames. Okay, so what's happening if I now run this command? So let's command this one for clarity. So now I just got, as I told you, 3, 2, because we didn't want the first one and didn't want the last one. And there is another trick that we can use. This trick is here, this one. So if I now ask my data frame if there is any volume value that is equal to a number, but it could be another condition, I can test if actually a volume would be superior to a value or inferior to a value. When I use this particular syntax, I create a Boolean list that I can use to filter my data. And this is a very convenient way to filter your data frame. If you're familiar with Excel, you have these functionalities. When you have a table, you can filter some data, but this is maybe not as practical as what you can do now here with Pandas, which is also extremely fast. So let's illustrate this. So print again my data frame here, okay, and then I'm going to print here, okay. So this is what I told you. We can now select the first 2 columns here, rows, sorry. And now I can create a filter. A filter here, it's a variable that I create, a Boolean. It will be a Boolean list. I can print my filter, just filter 1, okay. And this is the value that I have here, and I can do the same for another filter. Imagine now I want also to filter according to the value of Garth. So I can create this filter. I will print the second filter, and that's the result. So you see that we don't have the same the same Boolean vector. And now what I can do, I can just filter according to my data, according to filter 1, for instance. And this is what I have. So the filter 1, remember, was actually the volume had to be equal to 10.3. And I have, you can see in this final table, only lines where the volume is equal to 10.3. But then you might think, okay, what if I want to filter my huge data frame that might contain tons of different columns, and I just want to filter according to different values? So that's how this tool is actually very powerful. And it's called, you find online that is often called as a Boolean mask. And this is the typical structure here. So it's made of true and false Boolean values. And you can actually apply some rules. So you can, when you filter your data, and when you apply these rules, is you take advantage of bit calculation. So Boolean can be seen as a bit. And let me here illustrate what I mean when I say that. And you see how powerful is this tool. So I created here two series. So again, it's a one-dimensional Panda data frame. And I created it using arrange. So arrange, it's actually a series from 0 to 9. And using this condition, I can just now create my Boolean array that will be here false because these values are inferior to 3. I can do the same for my second Boolean list. And now I have 2 Boolean lists, and I will play with them, and you will see how nice it is. So what I can do, I can try to combine them in a different way. And one of the 2 keywords that we can use is actually the ampersand here. Okay, I'm highlighting here. So this is an AND condition. And when I say AND, I mean that both conditions should be respected to be true. So let me apply it now here. So you can see that you only see a true here when you had a true in the 2 previous series. And that's a nice way if you want to actually retrieve only values that are superior to 3 and superior to 6. So that's a little bit irrelevant example, but then you can apply the same functions to your lock method. Again, instead of ampersand, we can now use here the bar, and the bar means or. It means that to be true, you need one of the conditions to be true. So let's see the results. And you can see that as long as you see a true in one of these conditions, you'll have a true in your final Boolean string array. So you can apply this to a very long list of different filters. You can have a third one if you want, a third filter. You can also, there is another keyword that you use is actually the inverse of the Boolean, and you can just use a tilde, and tilde will transform all your false values in true and your true in false. And now if you do this, let's run it, you'll see that it is going to inverse this Boolean array. Okay, that's exactly what it did. And now let's go back to our lock function. So you can see how when you use lock, you just need to give as an argument a list of Boolean, and you can create 2 filters. Here I can filter my trees according to the value of the volume and the value of the height. And when I apply this now together, it gives me only the trees that actually have a volume equal to 10.3 and a height that is superior to 66. So that's really a very nice way to quickly access to all your Panda data, row by row. Again, I will now give you a little reminder. If you want to access to the columns, it's even simpler. You can just use here between brackets the name of the columns. So here we are just going to pull the column volume and the column height. We can only, if we want, we can just have actually one single column and so on. So for the rows, keep in mind, you have to play with either lock and ilock. And for the column, you can just here select the columns using this simple syntax. So that's the end about this recap on how to filter and how to access your Numpy array and your Panda data frame. Okay, so it's actually a very useful ensemble of tools that you can use when you're also interested in plotting your data. So let's now move on to the plots. And for the plots, we are going to use a new module, Matplotlib. So Mark, who actually provided most of the material for this lecture. So I would like to thank Mark again for all these fantastic lectures. And you have here a little history of Matplotlib, and so it has been created pretty recently in the history of Python, and it's really now used by the larger part of the Python community for plotting. So you'll have time to read this later, but as Mark summarized here very well to the question, what can Matplotlib can do? Well, Matplotlib can do everything, and I agree with that. It can do everything. I use it for everything. If really you are making your final figures for your paper, you can still, if you want, you can save your figures as a vector in a vector format such as PDF or PostScript, and you can rework them with Illustrator if you like to do that. But really, with Matplotlib, you will be able to make final figures for your papers. So it's actually extremely customizable. So you will see that it's pretty easy when you make plots with Matplotlib to increase by a lot the size of your script, because it's customizable, but you will have to use a lot of commands to make the perfect graph. So be aware that it will increase a little bit the size of the script that you will write as soon as you're interested in using this module. However, it's very flexible, and next lesson, I will also give you an introduction to an add-on of Matplotlib, which is Seaborn. And you see that Seaborn is a newest addition to all the Python modules, and it's a very nice module to plot quickly beautiful graphs. Okay, so Matplotlib as Panda and Numpy is not included in the standard Python package, so you will have to install it. So if you are right now on your environment, if you're already on your Visual Studio Code environment, you can just use your terminal. So, and you can then use either the conda command or the pip install command. Both will work. I would recommend to use conda since you have it installed. So if you have an issue with that, you can always ask a question on our Stack Overflow page. Okay, so when you have Matplotlib installed, it should, I think, be very straightforward. Then you have to import it. So again, we are going to use the import command, the same as similarly to what we did when we needed to import Numpy and Pandas. And here there is a little subtleties, is that we are going to use a pyplot submodule, and so we are going to use this syntax, import matplotlib.pyplot, and the keyword that will be used here is a PLT. Again, this is a very standard keyword, so I would keep it. There is actually then here very nice functionalities that is suggested by Mark. So if you're working on Jupyter Notebook, it's totally recommended to actually use this little command. It will actually help you to plot all your graph directly on your Jupyter Notebook in a very nice way. So when you start your new notebook and you want to make graphs, I will just copy and paste these 3 commands. So you have Matplotlib here and Numpy, and then this little command that will help you to have your graphs in your Jupyter Notebook. Let's run it. Okay, it worked. I can see a question from Anastasia, and I'm sure that Mark will have, yes, an answer about it. So exactly. So if you actually, when you use Conda, you can actually, using the option -n, you can give the name of the environment where you want to install your module. So it's very important to actually keep your module in a particular environment when you install them. When you start, it doesn't seem very useful, but you'll see that in the future, you might play with different environments and you want to make sure that everything is working together. So Mark just posted this command that I would recommend if you want to install on your ITP 2020 environment. Okay, so to illustrate the power of Matplotlib, we are going to use the random generator from Numpy array, because it's a very easy way to create an array that we can plot. So I think it's a good way to see and to show you how arrays and Matplotlib works together. So first, we're going to use a command, the command random.normal, which is included in Numpy. So it will create here an array that will have 1 dimension. It will have 400 elements, and all these elements will be random, but they will follow a normal distribution. And here we give actually the parameters for this normal distribution. It will be centered at the value 0, and the standard deviation will be 1. Obviously, you can change all these 3 different parameters if you want to change the type of values that you want. So let's do it. So then we create values, and then the first thing that you want to do is you can just call the command plot, which is the basic functional command of Matplotlib, and it will allow you here to just plot a list of values. So let's do it here, and that's what happened. So because here we're using a random generator, if I actually run this many times, I will have slightly different values. You can see here it's changing. So if you don't want this value to change, and it's not a topic I'm going to cover for this lecture, but we're not dealing when we play with computer with a real stochastic randomness. I mean, so it's a pseudo randomness, and we can actually, we can keep the random numbers the same by just putting a seed value. So a seed value can be anything really, but when you give this, this value, it means that it will exactly recreate the same random distribution. So let's try again. And now if I run it again, it should give me exactly the same distribution. Okay, that's exactly what happened. You can see there is a little peak here that we obtained twice. So when you give to plot just a 1-dimensional array, it will plot this value that will be on the y-axis, and the x-axis will be just the index of that 1-dimensional array. So here we had 400 elements, and so this is what we have. So we are printing this distribution of values for these 400 elements. So that's the simplest way to plot a single one-dimensional array. Again, if you want to play with a sub-indexing, you can now use, oops, sorry, I'm gonna comment this one. And here what I did is that I used this way to reverse the order of my array k value that we saw earlier in this lecture. It's actually a way to actually reverse your array. So you see that now this little peak, it's here, and we can also add a value. So here just I could add a value of 10 to the entire array, and that's really showing you how powerful are the arrays and how you can very quickly apply some operations to plot whatever you want to represent. Okay, so something also that you might have seen, and I think is very well explained here in this little section, is that we are also returning here the value that, so plot returns an object. And if we don't use this little trick, we return this object and we put it in this variable, which is underscore. If I don't do that, now this object will appear here. So it's fine, you can keep it, but if you get bothered by that and you do think it's an aesthetic, and I would say it's more a matter of keeping things cute in your Jupyter notebook, you can just put this object in this underscore variable. It's a way to just basically keep it somewhere when you're not interested to look at. So I'm going to run it again, and now you see that we don't have it. That looks nicer. It's a nice trick that actually I never used before. So thank you, Mark, for that. Yeah, let's move forward. So I just gave you some first example where we could plot one list, but we can plot actually one list against another one. Typically, if you have an array of X values and an array of Y values. So obviously it's important and essential here that these two one-dimensional arrays have the same length. So if they don't, you are going to have this typical error. So here, if one is actually shorter, it will give you information about the shape of these arrays, and it's important to keep it at the same length. So to do it here, we can actually use this very nice function called Linspace. It creates an array that will start from the value -5 to the values 5, and it will actually give you an array that has exactly the size of values. So len is actually returning the length of that array in a way that you make sure that this X array will have exactly the same size as your Y array. So now we can plot these values, and here you were plotting and your X were actually your index values, but now you can give to actually these X coordinates for this plot. So basically you can plot this way any X value against a Y value. Yes, so, okay, I see that there's, in my example, I just wanted to show you, so I just on values, I just wanted to illustrate that you can apply very quickly operations to an entire array. Here I just reversed it and I add 10. It's a very simple example to illustrate how quick it will be for you to play with these operations when you do also some plots. And sometimes when you plot, it's a very nice way to visualize how you actually changing your data. Okay, so let's move on. You can also do other things. So here, for instance, you can also have different curves on the same plot. So we have one curve here, but you might be interested to have two curves. So we are using here, again, the same normal function. So line 1 will contain an array that will be composed of 400 values. And the parameters for the normal distribution are different. Here it's centered at 0, and for the line 2 array, it will be centered at 50, so that we can nicely distinguish them. And then we can just plot one after the other, these two different arrays. So let me first comment that. So on Mac, I like this command, and then slash, I command it, and I'm gonna run it here. Yes, so you see I didn't use his little trick, so I'm printing this, this line. It's fine, and I can remove it just like that, up, nicer, okay. And now on the same plot, what we can do is that we can actually have two different curves, and we can do it at the infinite. We can have many curves on the same plot. We just need to actually call these plots functions one after the other. So of course, if you have many curves, you want to distinguish them, and you can play with the style of the curve. And I will here give you some examples. There are way more argument that you can use for the plot function. I will give you some examples that I like, so you can play, obviously. So the first argument is the data, and then you can put in different orders arguments that will actually change the style of the curve. So we can, for instance, for the first one, for actually the curve is centers at 0, as you can see here, so line 1. We can change the color, and we can actually change the shape of the marker. We can make it bigger here, like that. We can also remove the line. So here, the line style is actually empty, meaning that I don't want any line connecting my dots. For the second plot, I decided to go for light blue, and I can change also the width, the line style. So the line style here is a simple line, but you can have dotted line. We can also have one marker every 2 points. So here the marker is a cross that you can see here, and you have just one cross every 2 points. Okay, and you can also change the marker size. So I decided to make it a little bit bigger here. So there are many ways to really like change the render of your plots. Again, you'll see that Matplotlib is very flexible. And what you can do, you can give a title to this plot like that. And you can also put X and a Y label like that. Okay, here. And you can also, and this is the final trick that I used here, I didn't want my data to be squeezed. So I could define the shape of my plot here with this command that I have at the beginning. So basically I'm calling the function figure, and figure has an argument called fixed size that will take a tuple or a list that contains two values. The first value will be corresponding to how wide will be your figure, and the second value, 3 here, will give you will change the height of your plot. So if I want to make it a little bit more even, I can do it that way, and you see now it's pretty big. And it's actually important when you play with that, especially when you want to save your figure. That's something I will present next week, but that's an important way that can actually change also the quality of your figure. Something that we actually will discuss next week, I imagine. Okay, so when we had different plots, one after the other, they all appear on the same. We have two curves on the same plot. Now we can, if we're interested to have two different plots, we can create 2 different plots in a row. And the only thing we have to do is to use this command show. And as soon as you have a show, it will basically plot everything that has been actually plotted before using this command. So it could be like many plots. So you can have here maybe 3 lines with the 3 plots that will all appear on the same figure. But as soon as you have this line, it will create a break and it will show your figure. So here in this example, where is it? So okay, so actually, yeah, it's here. Okay, so I have a lot of things commented. So okay, so now you can see that we have our two curves that appear actually in different plots. Okay, so that's a very nice way also to represent them in Jupyter Notebook. It's actually very functional. So here I wanted to make it a little bit fancy. So I created a function called horizon lines that will create 3 horizontal lines. Basically, it takes as an input an array. I will just then create a vertical line that corresponds to the mean of that array. I can change here the parameters for this line. Order here is actually when you plot many traces on the same plot, you might change the order and of which trace should be on top of the other. So that's a nice argument to play with. And I'm going with the same function to plot another horizontal line that contains now the standard deviation. So I just take the mean and I can add the standard deviation divided by 2. I can do the same here for the standard deviation, the mean subtracted by the standard deviation divided by 2. And if I just now run my little functions, I'll get something like that. So the bold line corresponds to the mean, and the lighter lines correspond to the standard deviation. And you can see that they're actually nicely centered to the data that we created. I mean, it was supposed to be centered at 0, and this one was supposed to be centered at 50. So what I would like to highlight here is that when you are going to create your plots, you might be interested in creating many times the same type of plots. So I would encourage you to create your own functions that can plot all your data in a particular way, and you'll have then an entire ensemble of different functions that you can use to plot all your data, and you'll be happy to reuse them and modify them later in the future. So that's really a trick that I use all the time. I have many functions, and here this is just an example of how to add 3 horizontal lines, but you could basically use functions for anything. So when we say that Matplotlib, it's actually a very versatile, it's because you can also use loops and you can change the figure in many ways. Okay, so I hope that everything is clear so far. We are almost, we are already halfway, and I think we are on time. What I will present now is going to be more examples about how we can play with the data and different ways to represent this data. So let's continue. Okay, so that's, I think, an example that has been given by Mark, and I think it's a great example about how Matplotlib is a powerful tool. So let's go for that. So first, again, we're going to use this little trick so that we are going to regenerate exactly the same random series. And here we are going to actually make a very particular series because it will have 2 dimensions. So the first column will contain a normal distribution centered at 0 and the second at 1. And this is then the size of the data that we want to create. So you can, when you call the normal function, you can use this little trick to have a two-dimensional array. So let's run it and see the way it looks like. Okay, so let me first comment everything. So again, command slash, I think on Windows, it's going to be for you control slash, but I think it's a nice way to just step by steps see what's happening. So we are going to just print points. And that's the way it looks like. So you have 400 rows and you have 2 columns. So basically this is, yeah, so the first row and so on. So that's really like how powerful are all these functions implemented in Numpy. You can quickly generate some random data. Again, I think what I wanted to do here, I wanted to illustrate how we can actually play with the index. So what we can do here, I'm going to comment the rest of this line. I can take just the first two rows, and I can take any column. So if I do this, up, I'm going to print it just by returning points. No need to add print here, and that's what happened. Okay, so this is great. If I want to look at the dimension of this, I can use this method called shape, and that's the dimension. So 10 rows, 2 columns. Okay, everything is good. And I can do a transpose. So a transpose is another function that is included in arrays. It's great because from a data that is actually now that has 10 rows and 2 columns, you can swap the rows and the column. So let's see what happened. Now you see that the dimension changed. We have 2 rows and you have 10 columns, and that's actually very useful when you create some data and you want to plot series of numbers. So I'm printing points now. And if now I print the transpose and I can do this, okay. I knew it would not work. And let's see, I think it's because it's already transposed. So let's do it that way. And this is not exactly the way I wanted this to look like. Oh, I know, it's because points now contain the shape. That's not what I wanted. I just want the transpose values, and that's exactly the way I wanted to plot it. So now, because this data, as you can see, has 10 columns, it's going to actually print 10 lines that way. So if you give an array of n dimension to plot, and if you have many columns, it will actually print changing automatically the colors. It does it automatically. And it's a very nice way to using transpose and playing with the dimension of your data to actually plot multiple series of points. Again, 10 traces here, 1 line. This is, I think, pretty powerful. Okay, so there are also in the Matplotlib module different ways to plot the data. So so far we used only plots, but there are other ways. So you can, for instance, use scatter. So in that case, you just call it with this syntax, plt.scatter, and then you can give your points. So it actually take as an argument 2 arrays that will correspond to the x and the y coordinates of your plots. So okay, so I'm going to plot it here, and okay, so I have 2 points, and yep. So let's see. Okay, so we are plotting the first column and the second column. So what about if we just do something like that? Exactly. So now I'm plotting actually, yeah, in this, I'm taking actually the same X and Y coordinates. So that's why I have this plot, but I can create any array. So when I have a scatter plot, and I think it's actually easier here to play with the arrange, I can create, for instance, or maybe let's use this normal distribution. So I can create, and I just would like to show you how you can very quickly make a plot. So it takes, I think, a value like that, and then we have to give how many, let me check how we can use this function exactly, and we have to give a size. Okay, so let's go up. Okay, so then I can say the size. I can put maybe a size of 10. So I will here create X coordinates that will follow this distribution. It will be 10 points. And because it's a scatter plot, I want my y-axis to be also an array that has exactly the same size. And if I plot this, now I have, you can see this scatter plot because we have this random distribution. Again, I can change here the size, so I can put size equal 10. Okay, actually S, avoid ambiguity. And here I can change the size here. So let's see how it works. And then I can probably generate data. Okay, that looks exactly the way we expected according to this random distribution. So again, scatter, it's a nice function that you can use. What is important is that both arrays have exactly the same dimension. You can change the style here. And yeah, there is maybe, let me see. Yeah, so again, I didn't here I describe all the styles, but you have some here a nice example of how you can change the style of your points or your lines, and you can change here, for instance, the shape of your marker up. And I think there is a nice, we can use here. Okay, let me see how we can do that. I think we can make the points transparent. I like to do that. I don't remember, I'm not sure I remember the argument. I think it's alpha equals 0.1. Let's see if it's alpha. Yes, exactly. So I can make here my points transparent. I can change the transparency using this float that should be between 0 and 1. And playing with the transparency, you can see that I can actually have a nice idea of how my distribution looks like. Okay, let's play again. Let's make it more transparent. And yeah, I think it's a nice way to see that we had a normal distribution centered at the value 1 here for X and Y axis. Okay. So there is another way to represent the data. It's very useful. I'm sure that this is one of the first graph that you'll use is a histogram. And now for the histogram, we are going to use the function hist, HIST. It will take as a first argument the points. And then you can change the number of bins. And you can even change the range of your histogram. So again, I think I'm going to use this distribution that I like. Okay, here, make the example a little bit more consistent. Okay, and maybe I will decrease the size of my array, and let's see the way it looks like. And yep, that's the way it looks like. Obviously, if I have a distribution that is containing less points, statistically, it will look a little bit more messy. And of course, you can play with that. And now it looks nice because you have a better representation of your data. Again, you can change the range. I can put 0 here, and you'll see like just a fraction of your distribution. Okay, great. So we've seen so far the functions plots. We've seen the function scatter. We've seen the function histogram. And there is another way that is actually great. Often when you have two-dimensional data, you are interested in plotting this in a 2D graph. And in this example that has been given by Mark, you'll see how you can just plot a matrix of an RGB matrix. So in this example, we are going to use this function. So run init. Now it's not based on a Gaussian distribution, but it will create another type of a distribution of points. So again, I encourage you to look at the website, and just on a Numpy or SciPy webpage, you'll find information about how you can use this. I'll give you like an example here. So as you might know already, the colors image are generally, they have 2 or 3 or 4 channels to describe them. So it depends, I think it depends on if they're transparent or not. So you can describe actually most of the colors by actually 3 different, an ensemble of 3 different integers. And so we can create these integers with actually this command random init. You can read here all the details about it. What is important is that when you use this command, you are going to create a matrix. Actually, it's going to be a 3-dimensional data. So the 3-dimensional data will contain also this type of variable that actually positive integers between 0 and 255. So let's look at this function. So that's the result of this function. So first, this function took as argument 3 different values that will correspond for us to the width of our image, the height of our image, and 3 will be a 3rd dimension corresponding to the channels. So when you use this round int command, it will create this multidimensional data where you have here the 1st dimension. It's this row that has actually 10 rows. Then the 2nd dimension, it's here you have 10 columns. And then you have a 3rd dimension that is actually contain now a tree and symbol of column, as you can see here. So when you print your array, it's actually nicely printed in a way that you can have an idea of the structure of your data. It's a 3-dimensional data, so it's not easy to visualize, but I think you have an idea of how this function created a 3-dimensional random data. Okay, so now that we have created with this command lines, we have created our data, we want to plot it. And to plot it, we are going to use a new command called emShow. It's basically a way to show an image. So you see the details here, but there is a little trick that we had to use. So for emShow, the first coordinate should be I think X, Y, and then the third value will correspond to the color. And the way our data is actually it's generated is a little bit different. So to change the dimension, we are going to use the transpose function. And when you use the transpose, you can change the dimensions of your data. So I let you play with that. I encourage you to use the method shape that will give you an idea of the shape of your structure. So if I just print the shape here of EMG, it's going to shape, right? Okay, and now that's the dimension. Okay, great. And now I have an error, and I have to say I'm not surprised I have this error, because when I'm transposing my data, I overwrite my variable EMG, and it's always a little bit risky. So you can do that when you make an operation on an array. You can just overwrite your initial array, but then if you rerun the code, then your initial image variable is not the same. So it's always a little bit risky to do this. So I have now to rationalize my my array. So I'm regenerating my array like that. And okay, so that should be fine. And now I'm going to use transpose. So when I use transpose, I will change the dimension of my array from 1, 10, 10 to 10, 10, 1. And 1 here will correspond actually to the value of the color that I'm printing. So that's the result. So again, emShow, it's a great way to represent a three-dimensional data. Here, it's actually a good example. We can actually change the size of our plot. We can increase it now to have 10 rows and 10 columns. We are going to regenerate the data. So when we have such a long data, you can see that Jupyter Notebook doesn't represent all the data. It puts this dots so that you just have an idea of the data, but you don't print the entire array. That would be really pretty crazy on your Jupyter Notebook. Okay, so let's run this again, and now you see that you have a similar image, but you have way more, I would say, columns and rows for your channels colors. So that's a nice way to play with emShow. You'll see next week with a Seaborn that there are even nicer way to represent three-dimensional data, and I think Seaborn is great for that. Again, I'd like to show you the power of using the index. If you just want to represent a sub-region of this entire figure, you can use here the typical sub-indexing. Here we just taking 2 rows and I think two columns, and that's the result. So that's a big zoom on what we have here. And okay, so that's pretty much it with this emShow command. We still have 15 minutes, so I have to move a little bit faster. I'd just like to show you an example here where we can just add a legend. So to add a legend, we just use plt.legend, and it will then automatically recognize the label of each plot. So that's the way you have to implement it. When you plot, you can add information about the label. It's going to be printed on the plot here. But you can also, if you want, wherever on your plot, you can add some text. And for that, you can use the function text. You just have to give as argument the x and the y coordinates of your text, and then the string of the text you want to print on your graph. So there are many options to add some information to your traces. That's another example. For this example, I used the convolution operator. So if you are familiar with a signal processing, it's definitely something that you have used. I don't want to go in the details of how it is working, but I encourage you to look Wikipedia. On this link. You have an explanation of this convolution operator. That's a very nice way to smooth your curve. So in this example, what we do, we create an X array that's using Linspace, and this is the dimension of the array. Start from 0 and it goes up to this value, and we are going to have 100 values in that array, and then we can apply an operation to that array. And here we just apply a sinus to these X values. And we can just add a little bit of noise using the random function. And we can even add a factor to this noise that we have here. So I just multiply by a factor of 0.8, but we can change it. It's a great way to have an X and Y array that I can plot. So if I plot my X and Y here, it looks like that. Okay, if I change the noise, okay, it's a little bit less noisy. There are different ways to add some noise. This is here a very simple way. And then I just wrote a function that will actually smooth the trace. So this function is basically based on this convolve function, and it will move a box across the trace, and it will use this box to average the values. So it's a very simple way to smooth your traces. And here I'm showing you an example. I'm going to add a little bit of noise to make my example a little bit more clear. Okay, so I can smooth and change the size of the box, and I can then change the color as well. So the first one was in red, the second one is green. The size of the box is bigger, so it should give a trace that is a little bit more smooth. And that's what we have. So again, a couple of lines, you just plot, and you easily you can smooth your data. You don't need to understand how this function works. You can just call it to make it nicer. I created a function here, and at the end of the day, in one line, I have a smooth plot of my y-axis that was noisy at first. Okay, so I think I might give you more examples about how to fit a curve, because it is so important, and there are many ways to do it. I like to say that it is easy in Python because you will benefit from this function in the module SciPy. It's called optimize, and inside optimize, in the submodule, you have a function called curveFit. So the first thing that we can do, we can create a function with the shape of the function. So here's an exponential function. So it takes 3 arguments to describe this function. X will be the X coordinates. That will be the input for your function. You can create your X data again with a Linspace, and then just calling this function, you can now create your Y data. And you can add some noise to your Y data the same way that I've done it on top here. I'm adding some noise. So I'm just using this factor. I multiply by this normal distribution. So here the noise will actually follow a normal distribution. And now I have a noisy Y data that I can use to fit. So let's see the way it looks like first. Let's just plot my data so you can see it's a little bit noisy. Again, I can make it a little bit more noisy like this. Okay, and now I want to fit an exponential there. That looks like an exponential. So to do this, we just have to call this function called curveFit. What it takes, it takes as a first argument the function that we have created. So with actually the 3 parameters for that function, and then it creates, it needs, x coordinates and y coordinates, both needs to be arrays, same size, and what we return, it's actually, it will return 2 objects, and the first object will be the fitted parameters A, B, C, and the second object here, pickoff, will actually give you some information about the quality of the fit. I'm not going to discuss this here, but if I can just now, so I'm printing here, my parameters. So this is the parameters A, B, C that are the result of the fit. You can see that they're pretty much close to our initial data before we added some noise. So that's looks pretty good. And now we can just plot it. So again, one line. This plot line contains here the x coordinates and then the result of the plot here. That's a very nice way here, example of how we can unpack the result from the fit using the asterisk. We're adding here the color, we're adding some information about the label, and then because now we have the label, we can actually add the legend. And when we plot everything, we have now the result of our fit. And again, it's in a couple of lines we created some data that was noisy. We could play with the parameters, and pretty easily we got the parameters from the fit, and then we can just plot them in one line. So I think it's a very nice way for you to play with the data when you want to understand and try different fits. You can, with this function, write any type of function that you have in your mind and see what is the best fit to your data. Again, if you're interested in the quality of the fit, you'll have to use this object called pickoff. I don't have time to explain further this, but at least you have an example that I stole actually from the SciPy website, but it's just perfectly well implemented. Okay, and the last example is about the Panda data frame. So I will, probably next class, I will give you more examples about using plots on a data frame, but just to give you a little appetizer, we have 7 minutes right now. I can show you how we can plot data from a pandas data frame. So I was looking for an interesting data frame to work with. I don't know if you miss sport or not, but there is no more sport on TV, but still you have the great website from ESPN that contains a lot of data, and you can just, very simple, with one line, you can download this data frame. So for this data frame, in a nutshell, they ask 10 panelists at ESPN to describe how tough are different sports. And the idea was to find out what's the sport that is actually supposed to be the toughest. So we just run these commands. Let me just comment this here. And so I'm going to use this read Excel command that will directly read this data in this URL. Let's see how it looks like. Okay, so this is the way it looks like. So we have many columns describing different aptitude that are required for the sport. And we have also information about the total of this score for this aptitude. So N, for instance, is endurance. I think PWR is power. AGI, it's agility, and so on. So you can, if you're interested, you can here look at the descriptions for the different features. Sorry. Something I don't like about this data frame is that the index are integers, and I think it makes more sense if the index are the name of the sport. It will be actually easier to play with this. So what I can do, I can use this again great function called setIndex. So now doing this, it will change the index. That should be now the name of the sport. They should be unique. Let's see. Yes, that worked. So now the index is the name of the sport. So it will be actually easier to access the data. I can use ilog if I want to just decrease a little bit the size of this data. So just here for clarity, I will take just the first lines, and I will just take a couple of columns from the second to the 8th. So it's just a way for me to have a smaller data. So ilog, it's just very function useful. Okay. And so now I have a subset of my data. Again, I think this is maybe not what I want. If I'm just interested in the data that actually needs a lot of power, I can use lock. And if I want to use lock, again, I can typically use lock that way, as we have looked at this earlier during this lecture. And now I should filter and this data frame and keep only the sports that requires a power that it's superior to the score 7. So I should not have basketball, for instance. And yes, there is no basketball. So we have now a smaller data frame. I think if you want to play with the plot, it's maybe easier for you. So if you prefer to play with the entire data frame, it's up to you. But again, it's very easy to retrieve some data that way using ilog and lock. And I will, during the next class, I will talk a little bit more in detail about the apply function. The apply function method, I should say, it's a way to apply a function to an entire row, an entire column. So I just don't have a lot of time now to exactly give you the details because we have 3 minutes. It's a very nice way here. If I want to pull an average per line, or if I want to pull an average per column, I can just use the apply function, and I can use these axis arguments that will actually change the way the mean will be calculated. So 1 for line and 0 for column. And what I would like here to show you is that a data frame has actually a method already included. So if you want, you can actually call a histogram using the method histogram. I'm not sure if I'm creating confusion, but I would like here to make it clear, because you might find online some code that is actually using this technique. So instead of using plt.histogram, you can directly call the method histogram from that data frame. So if I run it, I can show you that I have now an idea of the average per sport and the average per altitude. So I have both my histograms. If I want to plot my histogram in the old-fashioned way, the way I described, I can just use plt.histogram of this data frame, and you will see that it will give exactly the same plot as this one. Actually, I have time to do it, so let's do it. Oops. Oh, that's a comment. Let's comment it. And yeah, so these two plots are exactly the same. one is called using plt.hist, and the other one is called using the method hist already included in the data frame. Another nice way to plot the data is that if you actually use the hist method to an entire data frame, it will show you automatically the histograms for all these different columns. So it's a very nice way and a quick way with just one line to have a summary of your data frame. And that's something that we are going to discuss a little bit more in details next Thursday. But there are many ways to plot Panda data frames, and especially with the seaborn, it makes things a little bit easier and a little bit nicer. So this is the end of this class. Thank you all for your attention. Thank you, Mark, again, for all the material that you provided. I hope that you have a good idea that with both NumPy and Pandas, you can play with the data and you can really plot it the way you want. All of these modules gives very versatile tools that you'll get familiar with looking at this great cheat sheet. Thank you all. That's, I think, now a matter of you playing with all these functions and being familiar with them. I think we can stop now the video